Imagine you have given a box and the attributes are width, height and length. And the question is, how would you manage all of these variables as a single entity? Hey everyone, welcome to my channel FameMac, and in this video you will learn about the traditional way of managing functions and data variables, and then we will see C++ constructs, and then again we will see member functions, and at last we will see memory alignment and padding. So we have given width, height and length. All of these variables will have the data type integer. And now we can pack all of these variables into a single object. And the definition of this single object is defined in a specific syntax, like the structs and classes. Right? And we will have to name that entity as a box. To be able to work on these variables of the entity box, we will have to define some set of functions, like the setters and getters. For the setters, we will have to prefix the name of these setters with box so that the other developers can understand that this function belongs to a certain kind of entity. Right? So we will define the setters like the box set width, and then box set height, and then box set length. Similarly, we will have to define some getters so that we can get the values of these variables from the box entity. So let's define box get width, and then box get height, and then box get length. But this was the traditional way of handling a single entity in C language. In contrast to this, in the C++ language, there is something else called classes. We define all of these variables inside the box class, and these variables called data members, which holds the data of that single entity box. And now we define some setters and getters to work on these variables or data members, and these functions are called member functions. We can also define some more functions called auxiliary functions, and these are also called the member functions, which can do some more work for our entity called box. For example, we can also define a get area function or get volume function, which can retrieve or calculate the area and the volume. In C++, we have some more keywords like public, private, protected. These are called visibility specifiers that define the visibility of a specific member. If a member is defined as public, that means it will be accessible outside the scope of this class. But if it is defined as private, it will not be visible outside the scope of this class, but it will be visible to the class members. And we will learn about protected keyword in the later videos in this series. Now, note that this class keyword can be replaced by the struct. Now, what is the difference between the struct and the classes? Now, the difference is that the default visibility in the struct will be public if you haven't defined any kind of visibility specifier. But in classes, the default visibility would be private. So this is the difference between the struct and classes. But note that this is not true in the case of languages like C#, because structs and classes have different meaning. Classes are reference types and the structs are value types. So this was the theoretical stuff. And now let's dive into the real code to see how all of these things work. So in the C language, we will have to declare a group of variables like the integer width and integer height and integer length, right? So suppose that we want to create two boxes. So we will have to prefix with the box1 and then box1 and then again box1, and we will have to duplicate this with this and the 2 2 2, right? So suppose that we want to create approximately 10 to 20 boxes, and that means we will have to copy each of these again and again. To get rid of this, we can take the help of structs. Structs are the way to combine these data types together, and we will not have to worry about the naming of these variables. We can just access these width and height and length from the structures. So let's create the struct called box and t, and it will have some attributes called width and height and then length, right? And now we can get rid of this. So let's create the main function, and now we can instantiate the objects called box1 and then box2, or we can just declare these box1 and box2 together, right? And now we can assign some values to these attributes, right? Like this, width equals to 10, and then box1 dot height equals to 10, box1 dot length equals to 10, right? And now we can also copy the values of this box1 to the box2. Note that this is the copying of the memory of this box1 to the box2. It is a byte-wise byte copy, right? But in the C++, if you're creating the classes like this class 1, or if you're creating the classes, then we will have to define the assignment operators and the addition operators, subtraction operators. But if you not define, then the copy will be byte-wise byte copy, right? So this is how we can work with a group of variables with the help of structs, right? So like with this struct, we can also create a class, right? Box t class like this, right? Integer width, integer height, integer length. But what is the key difference between the struct and the class is that these are the all members by default public. That means we can access these variables. We can access these variables outside the class scope, and that means we can access all of these variables anywhere, like box1 dot width or box1 dot height or box1 dot length, right? But if we are dealing with this class, then we can't do this, right? To get this kind of functionality here too, we will have to declare this function. Sorry, we will have to declare these data members public also, right? But in the struct, these are by default public, right? So we will not have to write the public explicitly. So this is the box t and this is the box t class. But C++ provides much more functionality than this. Structs and the classes both can have member functions. But what are the member functions? Member functions are the functions which work on these members, right? That means we can group all of these functions which work on the same data in a class, and we can name that class a single object name, right? So if you don't want to expose these variables, so you will have to write the private, right? And so how we can access the values of these variables? You can provide getters and setters. These are nothing but functions. They are the member functions, right? So let's integer get width, and this will return the width, right? Note that we can access any kind of data member from here, right? So this is the very good feature in the classes, right? This is why these are called members of this class, because they have the right to access all of these functions and data members, right? So let's get height and then return height, and then get length, return length. Like with this, we will have to provide the setters, set width, and we will have to take some value from the outside environment. Let's this, width equals to width. Note that I have used here the this keyword. This is a pointer to the object of this class, right? When we instantiate the object of this class, we will have to access the variables inside this class with the help of this keyword, right? Because this is the pointer, we will have to use here indirection operator. But we can also access like this one, but there will be ambiguity here because both of them have the same name, this local variable and this the class data member variable, right? So that is why we will have to designate this, that we are accessing data member variable in this class, right? So let's declare some height setter height, and then this height equals to height void set length integer length, and then this length equals to length. So here we are set up, and then now let's check here, and now we can't access here. Now let's create the width integer length integer and then height. Now let's box1 dot set width 10 and then box1 dot set height 10 and then box1 dot set length 10, right? And now we can get the variables like box1 dot get width and then box1 dot get height and box1 dot get length, right? And now let's print out width, and now let's box dot width like this, width, and then std and line, and now let's box1 dot height and then std and line, and then box1 dot length in line, right? And now let's include some header files, include iostream, and then okay, so we are set up. And note that we will have to also include here the semicolon, and maybe there's no bug. Okay, now let's test it. Now let's compile. Okay, now let's run it. Now you can see that we have the box1 dot width 10 and then height 10 and the length 10. Awesome. Okay, now what are the more features that C++ provides? Suppose that we want to access the width and height and length of this box2, and now you can notice that we haven't ever assigned any kind of constant value to the width, height, and length of this object. So what it will print? So let's do this. Let's copy here. Okay. Now let's replace this to 2, and then box2 dot get width, and then box2 dot get height, and then box2 dot get length, right? So let's see what it prints. Compile it, and now let's run it. Now you can see that it is printing very random values. Why it is so? Because these variables contain garbage values. They are the values not defined. So suppose that we want to assign some value when we create the object or instantiate the object of this class. So how we can do this? C++ provide the feature of constructors and destructors. Constructors are called when an object is instantiated of this class, right? So how we can do these? Note that constructors are also member functions, but they have some very special kind of declaration and definition. They have not any kind of return type, and the name of those functions must be matched with the class name. So let's declare a function which is of course our constructor, and we will have to provide the definition here. Note that the name of this function is same as the class name and it hasn't any kind of return type, right? Now let's print something here. Std say out default or parameter less constructor is called. Note that it has not any kind of parameter, and this is why it is a default constructor and parameter less constructor, right? So let's run this and see. Know that we have two default parameter less constructor is called, and this again, okay, right? So that means we have instantiated two objects, and this is true. We have instantiated two objects, right? And now we can do some assignment here, like the width equals to 0 and the height equals to 0 and the length equals to 0, right? And now let's print here. Now let's check and compile, and now you can see that it has the fixed values, that is 0, that we have defined in the default constructor, right? Or we can also write here -1 and the -1. Now you will see that it is printing -1. Let's see. You can see that it is printing -1, right? So this is how the constructors works. Now, what are the other features that C++ provides? You know that C++ provides the function overloading, and the constructor is also a function. That means it can also be overloaded, right? Suppose that we want to assign some values to the width, height, and length of these boxes when we are instantiating these boxes. Like suppose that we want to create some other box like box 3, and we want to assign some values like the 1, 2, 3, right? That means we will have to define and declare a parameterized constructor here, so that it will detect that we are calling, it will resolve that we are calling a parameterized constructor instead of default constructor. So let's declare here the box t class integer with an integer, height integer, length, right? And then again we will have to access the member variable here with the help of this keyword equals to width. And we can also note that we can also write underscore and here and here, and then we can access with them just by their name. We will not have to designate that we are accessing the data members with the help of this keyword, right? And then again length equals to the length, right? Now let's compile and see what is the output. We haven't ever printed here, right? So let's write a function which will print width, height, and length of these boxes. So let's create a void function print box, and it will take the box t class and box, right? And now it will print the values of the box. It will print. Now let's copy here. Okay, now let's box, and then box. Okay, so this will be very obvious to you because you have already seen my videos on functions. if you haven't already watched my video on the functions, then you can check out the link in the description I have given. So let's print the boxes. Okay, print box 1, and then print box 2, and then print box 3. Right, so let's std out box 1 in line, and then std out box 2 and then std out box 3. Okay, now let's print and compile. Okay, now you can see that we have the box 3 with the box dot width 1 and 2 and 3, and here we have -1 all, and we have the we have 10 here in the box 1, right? So this is how it works and how constructors are resolved. And now there is another thing which is called the destructors. When suppose that constructor is called when the object is instantiated, and we want to do some work when these objects get out of the scope. That means the control reach is here. So how we can do this? It is all possible with the help of destructors, but destructors are only useful when you are allocating some memory and you are changing a global value when you are instantiating, and then reverting back to it their original value, right? So in most of the cases you would not need this when you are working with the stack allocations or something else, right? So how you can declare destructors? Destructors are similar to the constructor in the declaration syntax. Like you will have to write the tilde operator and then the class name, and this is our destructor. And destructors will not have any kind of parameters, right? Destructors doesn't contain any kind of parameters. This is the main difference between the constructor and the destructors. Constructors can have parameters and the destructors can't have parameters, right? So let's write std out destructor is called. Note that the calling order of destructor is the reverse of the calling order of the constructor, right? This is the main point to be remembered. Now you can see that at last we will have the destructor is called, and it is the 4 time. That means we have instantiated boxes 4 times, right? So how it is the 4 time? This one and this one and this one, but where it comes the 4 times? So why there is more than 3 destructors are called? Why there is more than 3 times of calling of destructor? It is because destructors are only called when we have instantiated something class object, right? So we have done here this because it is the value type passing. That means we have copied the class, we have copied the boxes, right? So if we have defined the copy constructor in this class, then the copy constructor will be called, and if we have defined the copy constructor in this class, then the copy constructor will be called, and this object will get destroyed when this function reaches out of the scope. When the control reaches the end of this function, then this box will get destroyed. That means we have called 3 times here, and that means the 3 times it will be called destructor more. So you can see here that 3 times here and 3 times here. That means it will be called 6 times. The destructor must be called 6 times, like the 1, 2, and then 3, 4, and then 5 and 6. This is, if you don't know about the, note that the functions are called value type, when you call a function with the with value types parameters, then the objects are get copied into the stack frame of this function, right? So it is just like an instantiation, but when instantiating, the constructors are called, but it is not instantiation. It is not instantiation. It is the copying. That means we can define a copy constructor. We can also define copy constructor too, and that copy constructor will be called. And this is how to define. Now let's see how to define copy constructor, right? So let's box t class, right? And we will have to pass this box t class object by reference, right? Box t class, sorry, box only, right? And we will have to pass by reference. And now let's this width equals to box dot width, this height box dot height, this dot length equals to box dot length. Note that we have accessed box dot width, but we can't access box one dot width here because it is the out of scope the class, right? But we are here inside the scope of this class, so we can't access any kind of member, right? So let's spit out a message called the copy or cpy constructor is called. Now let's std and line, right? And now the box t class is copied 3 times because we have called this function 3 times. That means box 1 will be gets copied into the stack frame of this function when we are calling this function, and then again box 2 is copied into the stack frame of this print box, and then again box 3 is copied into the stack frame of this print box. So we will have to so we are expecting that the cpy constructor must be called 3 times. So let's save this, and now let's compile and run. Now you can see that we have copy constructor called second, and then third times, right? So the expectations are very good and the result is very good. So now it is all about the classes, and there are much more features, right? Like the protected keyword and much more things like inheritance and the interface implementation, virtual functions. Much more things are out there to learn about the classes, and C++ provide much more functionality like templates and much more things, right? So the next question is how we can calculate the size of these objects. To understand this, we will have to first understand the memory alignment. Now suppose that you have a machine of word size 32 bits. That means it can access memory a block of 4 bytes at one time, and the address of that block must be multiple of 4. Then it turns out that if an integer of 4 byte it is stored at address 0, then the machine can easily access it. And if that integer is stored at address 4, then it can also be easily accessible. But if the integer is stored at address 1, then it cannot be easily accessible. The machine has to do some more work. It will first access the word stored at 0, and then it will store it into a variable. And then it will access the second word stored at 4, then it will store this into a second variable. Then it will perform some bitwise operations. Word 1 will be shifted to left by 1, and then word 2 will be shifted to right by 3. And the result would be the OR operation of word 1 with word 2. To get rid of this kind of overhead, the compiler aligns these variables onto the memory addresses of multiple of 4. And according to this, size of the structs and classes changes. We can also conclude that the size of struct objects or the class objects would be multiple of 4 or multiple of word size. Now let's take an example. You have given a struct and a machine of word size 64 bits. And here we have assumed that the integer has 4 bytes. The first two integers can be easily be fit into the first word, and the third integer cannot be fit into the second word. So the compiler have to allocate the full word instead of just 4 bytes. Therefore, the size of the struct would be 16 bytes, not 12 bytes. Now let's take another example. Here we have char and another char and then double and then integer. Here we have assumed that char has 1 byte and double has 8 bytes and integer has 4 bytes, right? So the compiler will first allocate first one word, and in that word the first two chars can easily be fit, and they will consume 2 bytes of memory of that word, and we will left with 6 bytes. And in 6 bytes the double word would not be fit, so it will allocate the second word, and then as the double takes 8 bytes of memory, it will fully reserve the whole word. So we will have to allocate the third word. So the size of this struct will be 24 bytes. So this is pretty much for this video, and in the next video we will learn more about the object orientation, like the inheritance, abstract classes and interfaces, and virtual functions, at last friend functions.